Alright, so for the Pythagorean theorem, we must understand that this theorem is only applicable to right triangles. So what is a right triangle? A right triangle is basically any triangle that has one of the angles a right angle. So you see this square marking over here? This means that the triangle has a right angle. That means the right angle will always be 90 degrees. So the triangle could be in any formation as long as you know that it's a right triangle. The Pythagorean theorem can be applied. All right, let's move on to applications. So the Pythagorean identity is written out as a squared plus b squared, which is equal to c squared. And c squared being the hypotenuse of the triangle. So the hypotenuse, the triangle, is the longest side of the triangle. Notice how this is the longest side of the triangle. And then A and B could be any side except for the hypotenuse. So what this theorem says is if we know two of the values, so the two of the values could be A, B, B, C, C, A. All we need to do is know two values, and then we can find the value of the third length. So let's practice. Let's say you have a right triangle that has side lengths 3 and 9. Let's rewrite the Pythagorean formula, the Pythagorean theorem. A squared plus b squared is equal to c squared. So, since we know what a and b are, by the way, these could be interchangeable. So, b could be 3, it could be 9. Unless the problem explicitly tells you what a and b are and where they are, then these are interchangeable because addition is commutative. But we'll see when that changes later on. So, since we know what 9 is, or sorry, we know what a is, so we can plug that into the formula. 9 squared plus, and then b is equal to 3. So 3 squared, then that is equal to c squared. It's important to note that c squared does not equal c. So just by this formula by itself, it will not tell us the exact value, and we will need to solve for c. So let's simplify this down. 9 squared is 81. 3 squared is 9. So that is equal to 90. 90 is equal to c squared. Now, what do we need to do to get c, or the hypotenuse? We just need to take the square root of both sides, and that will give us our value c. So the hypotenuse of this triangle is equal to square root of 90. And this is our answer. Let's try another problem. Let's say you have a right triangle where you are given the hypotenuse 7. and we're given one of the side lengths, 5. All right, so let's first define each variable. We know that 7 is equal to c, and then we could use either a or b. I'm going to choose a for 5. So we have our formula again, a squared plus b squared is equal to c squared. Now let's plug in. Let's try and solve for b actually. Let's solve for b first. So we have this equation. How do we separate b? Well, we can just simply move a to the right side of the equation. So we'll have c squared minus a squared. That will be equal to b squared. All right, now let's plug in the values. So 7 squared minus 5 squared still equal to b squared. All right, 7 squared is 49 minus 25, and that is equal to 24, which is equal to b squared. Now, to find b, just square both sides. Or sorry, take the root of both sides. That is equal to, b is equal to the square root of 24. So that means this will be our answer. Let's try another problem. Let's say you have a triangle with a right angle, and you know that this side is equal to 10, this side is equal to 11. All right, let's define our values. We know that the longest side is equal to c, c being the hypotenuse. And let's just pick one, A or B. I'll pick B. So now we're asked to find A. All right, so let's plug these values into the formula again. A squared plus B squared equal to C squared. We want to find A, so C squared minus B squared is equal to A squared. 11 squared is 121 minus 100, because B squared is 100, and that is equal to A squared, which is 21. And then now to find A, take the root of both sides. We get the square root of 21. That is our answer. And that concludes today's quick lesson on the Pythagorean theorem.